All right, this is our last video in our exponential functions unit, and it's a great challenge and real-world connection problem all wrapped up into one. I encourage you to give it a try by pausing this video, trying it on your own, and then checking back in and seeing how you did. And this is also a great challenge for seeing how well you can use Desmos, the online graphing tool, because we'll use that quite a bit for this problem. So assume that I have $1,000 to invest for a few years, and I'm curious how long it might take to grow to $2,000 under different annual interest rates. So try interest rates of 1%, 2%, etc. through 12%, which is probably unrealistic, and collect data in a table and look for a pattern. So all we care about is how many years it takes for our money to double. And what you might not know is it doesn't matter if we're dealing with 1,000 doubling to 2,000 or 1 doubling to 2, it would have the same doubling time. Okay, so but let's keep going with our assuming we have 1,000 doubling to 2,000. Let's see. So let's go to Desmos here, and I'm going to write down some of the numbers that we see on Desmos, so I'm not flipping back and forth between Desmos and the note app that I'm working in. Okay, so let's give this a try. So over in Desmos, we can type in our initial equation. Y is equal, so we're starting with $1,000. And then I'm going to call this 1 plus A, because A is our varying interest rate. And that's all raised to the x power. Okay, so it's going to ask us to put in a slider for A. And using a slider is just going to make it easier to collect some data. My second equation is just going to be y equals 2,000, right? Because I want my money to double to 2,000. Another thing to do on Desmos, right now my slider is set for some just crazy big values of A. Like this would be, what, 240% interest or something huge. So we can touch either of the endpoints of the slider, and let's have A go from 0 to 0.12, and let's have it go in a step of 0.01. Okay, so now A is going to be each of those different interest rates. So remember, 0.04 is 4%. I need to get a very different scale going on Desmos. I need to get up to 2,000, and I don't know what my most years it'll be, but let's have X go out a ways. So if we only have a 1% interest rate, we can find that looks like it's going to take us 70 years. I'm just going to round to the nearest whole number of years. Okay, and then when we get a 2% interest rate, it should take us fewer years. It does, 35 years for a 2% interest rate. 3% is 23 years. 4%, this is the a little bit tedious part. 5% is 14. But while you're collecting all this data, notice if you're seeing any patterns. I hope you're seeing a clear pattern that the higher the interest rate is, the fewer years it'll take to double our money, right? That should be an obvious pattern, but there's another pattern that I'm looking for here. That was 9, will take 8 years. So 10%, which is 0.1, will take 7 years. We're almost there. And 11% will take also 7 years, rounded. And then 12% will be 6 years. Okay, so I'm going to go back to my note app and fill in the numbers. Let's see here. So 1% was 70, 35, 23, 18, 14, 12, 10, 9, 8, 7, 7, 6. All right. Do you see it? Do you see that pattern? This is the rule of 70. Some people call it the rule of 72. It's a rule of thumb. It's not going to get you absolute precision, but it's going to get you in the ballpark. So if you can take 70 or 72, I think 72 is the more precise value, divided by your interest rate as a percent, so you're doing a big division problem, that's roughly equal to your doubling time. Okay, so as an example, let's take 72 and divide it by 2, and we get about 35. Let's take 72 divided by 6, and we get exactly 12, right? 72 divided by 9 gives us 8, okay? So that's a really handy rule of thumb, especially when you're thinking about money invested in a bank account, how long it might take to double. And again, the cool thing here is it doesn't matter if you're doubling from $1 to 2, or from 15 to 30, or from 10 million to 20 million. It's the same amount of time to double. All right, super handy rule of thumb. That's called the rule of 72. All right, that's a good place to stop right there.